Okay, let's look at this 5.4. It's called the Triangle Inequality. It's our next section. And it starts with the Triangle Inequality Theorem. Statement of the Triangle Inequality Theorem is the sum of the length of any two sides of a triangle is greater than the length of the third side. Read it over. Think about it. Basically says that when I add two sides of a triangle together, they better come up with a length that's bigger than that third side. I add two other sides, better be greater than that other side. I have to do that 3 times with all the sides to come up with every two sides I put together has to be greater than the side that's left. Let's look at this and see how this works. We've got 4 different lengths of triangles here, or sides of triangles, 5, 8, and 12. We look at 5 and 8 and 12. Notice this red segment is 12 long. If I have a 5 and an 8, you can look at that and see that as those come together, they're longer. So if I put this end there and this end there, it's going to tilt up. Sort of like this, it's going to come up, but not very far. This is going to come up to about there, and then this is going to come up to about there, so that I have a little triangle. Okay, it's not coming up very far. Why? Because the excess is only about 1 inch. So a little triangle. Now let's look at this one. I have 40, and then 20 and 32. Notice that these two are greater than that one. So what's going to happen is I put this up, I'm going to have something that come up like this, and then I'm going to have, well, that's actually going to be quite a bit longer than that, isn't it? I'm going to have something that comes up like this, and then all of a sudden I'm going to have this, okay? So when I bring this around, it's going to look like, this would be a 20, this would be a 32, okay? This would be a 5, this would be an 8. Alright? Now let's look at this one. If I bring it up over here, I've got a 20, a 5, and a 15. Well, if I put these out, they're just going to lay right on top of that 20, aren't they? There's not going to be any space between them and the 21. Therefore, there's no triangle. Why? Triangle, I've got to have angles that are greater than 0 degrees in order to have a triangle. Let's look at this one. It's hard to see over here because there's only an inch difference. This one, it's going to lay on top of that 19 and still have space left. It's going to leave a gap. You're going to have an inch gap here in the center. It's not going to make it. Okay, so that's the concept is you can't just take 3 any old sticks and make a triangle. Those sticks have to have a certain relationship to each other. Okay? Now, let's take these and do some little work with them. What we're going to do is we're going to add the first two and see if it's greater than the third. Okay? 5 plus 8, is that greater than 12? 5 plus 8 is 13. Yeah, that checks off. Take the next two. 8 plus 12, is that greater than the one we left out? Well, yeah. Because that's 20. Is that greater than 5? Yes. And I take the outside two. 5 plus 12. Is that greater than 8? Well, that's 17. It most certainly is. So this one passes all 3 tests. We have a triangle. And we showed that. Let's look at this one. Let's take the first two. 20 plus 32. Is that greater than 40? Yes, it is. Because this is 52. It's greater than 40. That works. Let's take the last two. 32 plus 40. Is that greater than 20? Well, 32 and 40 are both greater than 20. So as a result, that most definitely works. Okay, because that's 72. Let's take the outside two. 20 plus 40. Is that greater than the one that's left? 32. Yes, it is. And we have a triangle. Okay? Now let's look at this one. Take the first two. 5 plus 15. Is that greater than 20? Well, 20 greater than 20? No, doesn't work. We don't have a triangle. Do we need to go any further? No. If one of them doesn't work, it doesn't work. Okay? We're through. Now let's look at this one. First one is 8 plus 10. 8 plus 10, is that greater than 19? 8 plus 10 is 18. Is that greater than 19? No. Do we have a triangle? No, we don't. Do we need to do anything else? No. We're finished. No reason to do the other calculations. Why? Because one of them doesn't work. If one of the calculations fails the theorem, then we do not have a triangle. Now another type of problem we need to work out, what we did first was we looked at 3 lengths of sticks and said, wow, can these 3 sticks make a triangle? What do? We added 2 of them together, see if it was longer than the third. Added another 2 together, see if it's longer than the one left out. Added the last 2 together, they're longer than the third one. And if any of those don't work, we do not have a triangle. That's one type of problem. Can I make a triangle given 3 sticks of any length? Now, the other problem we need to look at is this. I've got 2 sticks. I'd like to know how long the third stick has to be in order to make a triangle. Because if the third stick's too short, I won't make a triangle. Or if the third stick's too long, I won't make a triangle. What? If it's too long, yeah, I won't satisfy the Triangle Inequality Theorem. It just simply won't work. So let's look at this. Now you can actually sit here and trial or error this and go, okay, I'm going to do this little addition problem and see if I can come up with this and go with it. Or you can do a little process that works every time. What we want is, we'd like to find out x, okay, that is greater than some number and less than another number, and that x length will make those 3 numbers into a triangle. So we would have 5 and 3, and whatever x is would make a triangle. What's the relationship over here we need so that x is bigger than something? What we found is this. If you'll put these in order where the larger number is on top that you know, the smaller number is on the bottom, and if you'll subtract them, that will be the low limit on your range. On your domain, okay? And if you'll add over here, that will be the upper limit. Add the 2. So, you have a number, a length of a stick between 2 and 8. That will make a triangle with lengths of sticks 5 and 3. Try it out. Remember, it has to be larger than 2 and it has to be less than 8. Anything less than 8 cannot be equal to 8, cannot be equal to 2. Why? Because if it's 2, 2 plus 3 is 5. Doesn't work. If it's 8, 5 plus 3 is 8. Doesn't work. What's this one? We want an x that is bigger than something and less than something. Well, subtract. 42 minus 19. Oh man, that's hard. It's about 20 to 22, 23. We got that? 12 minus 9 is 3. 23. So, x has to be bigger than 23. What's it got to be less than? Add them. 1, carry that, 61. Okay? So your third stick has to be between 23 and 61. Well, let's try that. 23 plus 19 is 42. So if it equals 23, that's not going to work, is it? It has to be longer than 23. How much longer? any longer. If it's 61, that's what that equals. Okay? Let's try this one. We want an x that is less than that and greater than that. What do? Subtract. 21 minus 13, I think we come up with an 8. So we've got to have a stick bigger than 8. 8 plus 13 is 21. That's equal, has to be 8.0001. Add them together. 34. So the stick has to be between 8 and 34. Okay, let's take this one. We want an x greater than something and less than something. Subtract, we get a 3. Add them, we get 15. That's the triangle inequality. Any two sides of a triangle have to be greater when I add them together than the other side. You have to do that 3 times. If any of those come out with a length that is less than the other side or equal to the other side, you don't have a triangle. Now the problem is I have 2 sides. How long a stick do I need to make in order to make a triangle out of those 2 sides and a 3rd stick? Those are the problems that you have. That's the triangle inequality.